Hello, I would like to work out this problem here. I saw on Quora that any number containing all ones as digits cannot be a perfect square. Well, that was maybe something challenging for me. It was not perfectly clear if there was eventually a possibility for me at first. So I wanted to work that out, and I was inspired from Mr. Grunbaum, Mr. Klaus Grunbaum, who stated that you should take that number modulo 4. But he didn't say why you should do that. So that triggered my spirit to find out why modulo 4 should be investigated. Well, and then at a certain time I came to something interesting. Something interesting, simple. I said, yeah, any integer can have two forms, the form 2n or form 2n plus 1, and is also an integer. That can be 0 or non-zero. I limit myself to the positive integers because we are not taking into account negative ones. And okay, the square of 2n will be 4n square. And I say, okay, this is the form 4n. So if you take that form modulo 4, it will lead to 0 as a result. And if you square the 2n plus 1, you will get to 4n squared plus 4n plus 1, and this is a form 4n plus 1 because, yeah, it is modulo 4 will lead to 1 as a result. Okay, good. Right. And this is interesting because I will now have something interesting. I will now have a possibility to show why the number with all ones cannot be a perfect square. So I rewrite that number as a number ending on 0, 0 plus 11. And I say that 11 is also written as 8 plus 3. And this will give me the form 4n plus 3. Oh. So it is not 4n or 4n plus 1. So it is not a perfect square. I'm done. Unless. Unless, yes, Mr. Grunbaum said, okay, you can take any number with all the same digits, it will not be a perfect square. So that was not perfectly clear for me at first. I wanted to work it out for the 2. So for the 2 I had the conclusion that it was the form 4n plus 2. So yeah, not a perfect square. Okay. Then with all 3's ending on 32 plus 1, okay, form as 4n plus 1, a possibility, eventually a perfect square. But, yeah, then we needed another property of any integer. We can write any integer as a form 10n plus d, and the d is the last digit of the integer, right? So if you square that, you will get to the form 100n squared plus 20nd plus d squared. Okay, that's the form 10n plus d squared because it is a multiple of 10 plus d squared. And the last digit comes from the last digit of d squared. Yeah? And 3 does not belong to possible last digits of the square of a digit. What possibilities do we have? The first is 1, then you get to 4, 9, 16, 25, 36, 49, 64, 81. So I stated all the possibilities for squares of one digit. And 3 does not belong to the possibilities. So based on that property, any number with 3's, the ending on 3 cannot be a perfect square. I go on because I'm well on my way now. But maybe I will still have some problems. Yeah, the 4's. With all 4's, it gets to that form ending on 44, so it's 4n again. So possibility for perfect square. But there is something I have discovered. I said, okay, it's with a relationship to the number with all ones. It is 2 square multiplied by that number. So you have the multiplication of a perfect square and not a perfect square. And that is easily to understand that the result won't be a perfect square, because you have to have a square on both terms. Yeah, both terms should be a perfect square. To have the exponent out of the brackets. So yeah, right. So and the 5. The 5 is leading me to a 4n plus 3. Okay, not a perfect square. The 6, all the 6's. 64 plus 2, 4n plus 2, so not a perfect square. With all 7's, that's 76 plus 1 at the end, 4n plus 1. Okay, an eventual perfect square, but 7 does not belong to possible last digits. You can understand that, and you just have to state again all the possibilities from 1 up to 9 and square those possibilities. Yeah, the form with all 8's is form 4n, but 8 again does not belong to possible last digits. And form with all 9's will lead to a 4n plus 3, and that is not a perfect square again. Okay, so we're done. Hope you liked it. Okay.